All right, guys. Yesterday we talked about how many solutions there are to a specific system. We want to figure out the number of solutions without doing what? Without solving. Okay? Now there are a couple ways to do that. I think the easiest way is the one we're going to go over today. Okay? Now yesterday at the end of class we were looking at graphed equations of a system. Like both the equations of the system were graphed. And we had 3 different graphs, right? And then from there we came up with this idea about how we know if there's one solution, no solutions, or infinite. Does anybody remember what those ways were? Okay. So it involves slope and what else? Y-intercept. So slope and y-intercept. Now, if I want to examine the slope and y-intercept of an equation, what form does it have to be in?
mx plus y equals mx plus b.
Good. So the first step in determining the number of solutions is to rewrite both equations. Oh, both does not have an E at the end. Both equations in y equals mx plus b form. Now this form, what's the m?
The slope.
The slope. What's the b?
The y.
The y what?
Intercept.
Good, the y-intercept. Okay.
Yeah. My binder's gone.
Long, give it back.
I don't have it. Do you have it?
Jordan, give it back.
I had it in this class. I know it because I had to put my count paper out of it.
Oh, here's your box.
It's like gone.
All right, guys. Maybe want to make this table in your notes. Okay. So we have one solution, no solutions, infinite solutions. Rebecca, what color is it?
It's clear.
Yes.
It's got lots of pretty colors in it.
You take notes, we'll find words.
So weird. It's like gone though.
Yeah,
Oh
I'm sure
my
that.
God.
Jordan Long will help us find it later. All right. So what did we say yesterday? When there's one solution, when what happens?
Is no solution on what?
Well, there's one solution.
When the slope is
Okay, good. When the slopes are different. So slopes are different. The slopes are different. We have one solution, right? Did we say anything about the y equals or the y-intercepts? No. That's because the y-intercepts, they could be equal, they could not be equal, right? So if the slopes are not the same, then we have one solution. And we know that because if I graph 2 lines that have one solution, how many times they intersect? Once. If they intersect once, that means their slopes are not the same. No solutions. What is that? What do those graphs look like?
on the same.
Straight line.
Well, they're all straight lines along.
They're parallel.
They're parallel lines. What do we know about parallel lines? We know about their slopes.
They're the same.
Okay. So they have the same slope. Right? What about their y-intercepts? Different. They're different y-intercepts. I guess I could just wrote different up here and so the slopes are different. It's only in the slope column, Mr. Grant. I just wrote different. And Rebecca could see it.
No, he was sitting back there. I found
Okay.
it. Some people had it over here. I don't know who it was.
Okay, good. Now, infinite solutions. When we have graphs of infinite solutions, what do they look like?
Both on the same line.
They're both on the same line. So they're both on the same line. That means the slopes are
Different.
The same.
the same. And the y-intercepts are
Same.
the same. So if you can take a system and write it in the form of y equals mx plus b, and then look at the slopes and the y-intercepts, then you can figure out how many solutions there are without actually solving. Does that make sense? Are there any questions? No? So, I have 3 examples I'd like you guys to look at. Here are the 3 examples. Oh, wrong way. So, how many solutions are there? Can everybody see example 1, 2, and 3? Can you see it? So I want you guys to look at example 1, 2, and 3, and I want you to figure out how many solutions are there. So what do you guys need to do first?
Put it into y equals mx
So put it into y equals mx plus b form? So you said, Faith? Yeah? Okay. And then compare the slopes and the y-intercepts. So take each of the 3 equations and rewrite them in y equals mx plus b form. Josh, okay? Can't figure out, please.
solve it first.
Nope, you don't need to solve it. Just rewrite each example in y equals mx plus b form. Why you look so sad?
Because I'm trying to figure out how to do it.
Just use algebra. Move the x's to the other side and I'll through. So this is good review for solving by graphing if you forgot how to do this. This is easy. Then do it. Jessica, how's it going? Kind of.
Like you started it.
Yep. I'm sorry. Question. Oh, we're not working that right now.
No, he'd be the nerd.
Go to
Alright guys, sounds like we're done. So, can I have someone write? Why are we talking then?
Because they think they're amazing.
Yeah, let's get them done then. Okay?
What? I don't know. I don't even know what I said.
If you have questions, ask. Let's stay on task, please. So you gotta give me each one because I'm supposed to be from, right? You gotta take this one and get the X off this one. That was a good concept. Thank you, Juan. Nope, you're just writing each of them in y equals mx plus b form. We're just trying to figure out how many solutions each of those have. Okay?
We divided by 1, right? It don't make it happen.
So we don't gotta solve anything, not use calculator, not use anything.
Nope, you just have to get the y's by themselves in each of the systems.
Oh, that's one.
Then once you get the y by itself, then you're done. And you can figure out how many solutions it has. You're gonna volunteer to write example 1 on the board, the y equals equations. Rebecca? Volunteer to write example 2, the y equals equations.
Yeah, shall we solve them or do something right?
Just write the equations. Example 3. Y equals equation. If you finish and you'd like to, then just let me know.
I can do it. Made my hand go up.
I'm sorry. Thank you, Rebecca. Anybody got example 3 yet? Done yet? They want to write them up? Trying?
Why did it have to be this?
Because you guys don't like working with decimals. Nope, we'll get that in a second. Thank you, though. Anyone got 3?
I think it's wrong.
Right it up there. I'll play with or not.
It's wrong.
Sure, it's that thing. Thank you, Andrea. No gentlemen representatives today. Interesting.
I don't want to touch the board. You need to finish. Yeah, we've come to
Rebecca, thank you. You said you thought you were wrong.
It's right.
That's right.
Yeah.
Good job. Alright, so here's our 3 y equals equations for example 1, 2, and 3, correct? Right? Does anybody have anything different than those? No? Okay. Those 3 are correct. So if you have something different, then you and I can try to figure out what you did incorrectly. Right? Alright, now, if I look at those 3 equations, right? Try to figure out which ones have the same slope, the same y-intercept, or nothing alike. What? Okay. So try to figure out which ones have the same slope, the y-intercepts, so we can determine the number of solutions. Alright. If I look at example 1. Oh, I shut this off. There we go. If I look at example 1. One small adjustment, Rebecca, do you know what it is?
That's not a negative.
And this x should be. Nope, this one should be. Oh yeah, try the both positive.
Oh yeah.
Because the y's are negative, right?
Yeah.
So, what do we know about the slope here? They're the same. What about the y-intercepts? They're different. So if the slope's the same and the y-intercepts are different,
Solution.
no solution. Hold on a sec.
I thought that was. I
Wait,
didn't know
wait.
that.
Yeah, that should be a -4 too. Got to divide by your -1, didn't you, Rebecca? That's alright.
Yes, I
Yeah.
did.
That happens. Alright, so take it back. Slopes are the same. The y-intercepts are the same. So how many solutions? Infinite. Infinite solutions because the slope is 1, y-intercept is -4. Exact same line. Right? Okay, I'll be on the thing, Rebecca. Alright, example 2. Okay, these are correct. What do you notice about the slopes? They're the same. Y-intercepts, they're different. So, how many solutions? No solutions.
Oh.
Yep, so I made that chart, right? Last one. What do you know about the slopes? They're 0.5 and 0.6, right? Slopes are different, so
It's one solution.
one solution.
And can the y-intercept be the same or indifferent?
Yep.
Okay.
Either or, doesn't matter. Because the y-intercept is the same, but the slopes are different, that means they cross at the y-intercept. They cross on the y-axis. Okay. So, one way we can do that, guys, is use the y equals mx plus b form. Now, that way I know works every time, and I think a lot of students can have success with that one. Now, the other way is a little bit more intuitive in nature. Okay? You look at the ratio between your x's and y's. Okay? So, if you like this way that I had to be done already, great, use that way. Okay? I'm going to show you just one other quicker way. Right? If we have everything in the same column like we do when we're solving systems, okay, I need to look at the coefficients on each of these. Okay, I'm going to give myself a little more space. Okay. All right. Now, what's the coefficient on this x right here? 1. What's the coefficient on this y? 1. -1. What this one? 4, right? Okay. Now, if I look at the ratio of my coefficients, which means ratio means divide, right? My x's I have 1 over 2, right? Right, you guys see that?
Yeah.
My y's I have -1 over -2, right? Okay. My numbers have 4 over 8. Now these all reduce to 1/2. Since all those ratios are the same, that means infinite solutions. Okay? Since all those ratios are the same, infinite solutions. Let's look at the next one. What's my number on the y's? 1. Okay, x are there, 12 and 7. So, ratio 1 over 1, right? 5 over 5. 12 over -7. Which ratios are the same? The first two, right? These two both equal 1 over 1, don't they? This one does not, right? So, if our y over y equals our x over x, then we have, what was example 2? No solutions. And then the last one, is there any common ratio here?
No.
For x's we have 1/3. For y's we have -2 over -5. And for numbers we have 0 over 2.5. So this one is 1/3. This one is 2/5. This one is 0. If there's no common ratio, that means what? One solution. Either way works. If you want to use the ratios, you can. If you don't want to, that's fine. Any questions? Any questions? Okay. For the one solution one, guys, you could also have if x and x in the number have the same ratio, that would work as one solution. Or if y and y in the numbers have the same ratio as one solution. And that's why I don't really like this method, because there's kind of this if and then situation, whereas the other way you just solve for y equals mx plus b, and then compare the slopes to my intercepts. Any questions? Any questions?